This week on Maker Update, we're at OpenSauce 2026, checking out a t-shirt cannon you can ride on, a robot for your Boba, a glowing moiré, and a chicken gimbal without the chicken.
Hey, I'm Donald Bell, and we're here at OpenSauce 2026 in San Mateo, California, and people have brought a ton of cool projects to check out, so let's go take a look.
Hi, I'm Paige Powell from Powell Creative Studio, and I built the world's largest Game Boy Color. This is Nick Alvarez.
Hey guys, how's it going?
He's an electrical engineer.
Yeah.
And he also helped build the world's largest Game Boy Color.
This is true, I helped build this. We wanted to make it pixel perfect, so like actually have the amount of pixels that a Game Boy has, but just blow it up. So we built a video wall behind there. It's all on a little mini computer with like emulation, but there's a lot of like custom firmware, custom software that was developed to get it on the electronic side. So I did all the electrical engineering, all the electronics. Yeah.
So for me, the story behind this is I've been building like large-scale prop builds for a while, but under other people's names. So I've done a lot of prop work for the Mark Rober YouTube channel, for OpenSauce, like builds that come here, but I've never gotten to represent them as my own work, and that's something I've always really wanted. So I wanted a Guinness World Record that would have my name on it, and that's what we did. We spent about 8 weeks building this, lots of hours, a lot of time went into it, and people are just loving it. I mean, we upgraded this one. This one has a subwoofer in it. It has 2 tweeters, a mid-range speaker. The audio's awesome. It can emulate a Game Boy Color, original Game Boy Advance. We have PC games on it. It's pretty decked out. And then the other cool thing is, like, when we're not playing it, this can just sit in our shop and play ambient art and be our speaker system, because it's an awesome speaker system.
This is Infunity. We are a Pacific Northwest-based studio, and we create interactive light installations for events, for event organizers, for content creators, and set designers. What you can see behind me here is called the gate. This is 2 overlapping grids called a moiré, and what your eyes pick up on are those points of interaction where they overlap, that positive interference. It's truly the intersection of art and tech. And you can control it with your hands too. If you see over here, we have somebody moving their hands across these 2 different sensors, and that changes the rotation of the grid of the moiré pattern, creating that beautiful interference that you see. What I can tell you is that it is running off of a small microcontroller, and the feedback loop is starting from 2 individual LiDAR sensors, which are just slightly adjusting the latent rotation of the moiré pattern. It's driven by a set of 2 stepper motors on the back here on the outer perimeter. And that lets us see the full pattern.
My name is Jake Shimada. I'm part of the Tello Trucks team. And right here is Apollonia. This is our first chassis that we ever built. So over there is our 2 prototypes. But before that, in our seed round, we actually built a chassis to kind of show the engineering feasibility of having a truck with motors in the front, a battery, and a 5-foot bed in the back. So also having 5 seats. So this was kind of the test chassis, and then after it was retired to get started on the 2 prototypes, which are more indicative of what our production will look like, our co-founder Yves Behar from Fuse Project took it and he made this Burning Man car. So it has a bunch of lights and all of these cool bubbles on it and this crazy sound system. Inside is a couch, and the best part is it's basically a full EV in this awesome Burning Man car, so it's definitely one of a kind. So it's I think it's by Industrial Design. They basically made all of the windows. Each one of these windows has lights inside of them, as well as they all open up. There's a good amount of like them that kind of open up for the speakers, but also just have some visibility inside. And yeah, there's like a cool couch in there, which the driver's seat can go from driver back to couch, and has just a really cool place to hang out and has a great sound system.
I'm Kevin. This is the Boba vending machine. We call it the Bobamabob palindrome also. I built it here with Jeremy. Our friend here is also helping out. It's basically just a big XY gantry, same thing that a 3D printer might use. And we have it go through every little station. So we got toppings, we got the cup, we got ice, we have a sweetener, syrup, and we also have a sealing machine. Boba shops use this. That's how you get the plastic film on top of the cup. So we have stepper motors, and main thing is stepper motors and servos. I think something that's really tricky is the topping dispenser. We have these 3D printed augers, not food safe, but it's just really hard to move like goopy liquid. Like we don't want to move all the liquid, but we want to move the solids. So that's why we have them at an angle. This cup dispenser is also really finicky. There's a little worm gear in there. We bought it pre-made. We set up some relays to kind of count the rotations, so it'll dispense only one cup. This is the electrical area. These are micro step drivers for the stepper motors. I know there's smaller ones, but these worked, so we just went with them because it was easy. We got an Arduino Mega here. It has an Ethernet hat on it, but we don't use it. We were using it, but it wasn't working that well, so we stopped. DC power supply. It's 5 volts, 12 volts, 24 volts. Yeah, this is for the router that we stopped using for the Ethernet. But yeah, that's kind of the gist of the machine. We got diaphragm pumps to pump the liquid up.
My name's Zach Solly. I work for Acronym, and we're here showing off our t-shirt cannon robot that we built. So it's a 8-legged Strand Beast inspired design, all kind of engineered in-house, fabricated ourselves. We added the seat, t-shirt cannons, all that. We started on Monday to bring it out here because we thought it would be cool. But we're an agency, so we do a lot of creative technology, which means kind of whatever it needs to mean. But for us, it's like we do a lot of custom mechanical, like mechatronic stuff, a lot of custom electronics. We have some of our custom in-house circuit boards that we've designed, so a lot of DigiKey components on that. But yeah, so we do a lot of just events. Anything that has kind of a technology lean to it is what we do. So we found Theo Jansen, his Strand Beast, kind of like that inspiration. We kind of use the same math, design our legs, and then just very rapidly iterate it from originally the thing would collapse, and we're like, well, we can't use belts, we need to use chains. We're like, oh, it can't go up hills, we need a more powerful motor. And then we were gonna take it on a worldwide tour, so we're like, everything has to be 12 volts because we need to be able to source batteries in each country if we can't get them shipped there. So it was very intense. What ended up being 4 months to build 3 robots from scratch that could be collapsed down, put in a crate, shipped across the ocean, and set up within about an hour or so at each location. And then this was the original prototype. We stripped everything off of it, put a chair, put controls, and put t-shirt cannons on it.
Hi, my name is Laura Matthews and I have made Big Wings. I'm really interested in bird anatomy and kind of recreating it in order to understand it. So these are based on a phoenix puppet design that I did originally, and I've scaled it up and made them wearable, and yeah, here we are. So this set is birch ply, which is nice and light, but it's nice and strong, and the feathers are made from polypropylene, like milk carton material. But it laser cuts really nicely. Lightburn have sponsored me to be here, which is amazing. They've been really good to me. So I think maybe people don't see that each of the feathers have a linkage connecting them to the one in front and behind, which means that instead of the feathers, if you just stitch them together, they open sequentially. But because they have like a ligament between them, they open much more naturally, like an actual bird wing. So it's like a hidden thing, but I think it just really improves the way that it opens. So originally I really wanted it to be attached onto my arm, so my arm would open and then the linkages would all open afterwards. But yeah, it meant that I didn't have free control of my arms, and it meant I would have to be a bird all the time. So yeah, connecting to the end one gives me the most sharp motion, And pushing up is quite simple. It's quite easy. It's just like sort of rotating the wrist starts to open it, and it just, I don't know, it feels nice.
Hey, look who I ran into. It's Becky Stern.
No, and I brought my vapes in.
Let's see if we can get harmonized going. There we go. Ooh, there's still a little flavor in there too.
I know, okay,
Yeah.
I ran them through the dishwasher and I cleaned them with alcohol after every use.
Yeah.
And they still taste like vape juice. I'm sorry. I can't do anything about it. The yellow one's starting to not taste like anything anymore. But seriously, they're super clean.
Yeah, no,
but that oil, I think it's inside the plastic.
I was appreciating it. It's like, oh, it's like, you don't get a little flavor when you play guitar, right? But the vape
Somebody
thing,
suggested that I make it as an add-on instead of the vape, it's in addition to, so you actually have to vape to play the instrument. And I'm like, man, this is about e-waste, people.
it's about making music with good taste.
I see what you did there.
So my name's Bob. I started this company called Pantheon Design with my friends with this whole idea of making really good 3D printers, specifically FDM ones. And over the last few years, we finally figured out how to essentially print parts that were really homogeneous, so they didn't run into very many strength problems that you normally think of with FDM parts. And I think today they're probably the strongest in the world by a decent margin. So we thought there wouldn't be a better way to show that off than to print motorcycles that are quite fast and then race them at open source for everyone. So like at a high level, it's a nylon 12 derivative with like as much fiber loading as we could shove in without it jamming. And then we put in lubricity modifiers and then more fiber, and it's just as much fiber with nylon that bonds really well to itself as we could. So weirdly, most parts are quite sparse. I'm gonna grab something for you. So this is a fork leg. You have to just feel this for a second with your camera. But, so it's like 400 grams. So most of the parts are printed with like a 2 to 3 millimeter shell, and then like 5-10% infill. We're printing strong enough parts now that you don't actually need them to be that solid to like be a motorcycle fork, which is pretty wild, right? Telescopic forks are kind of a nightmare to print because you need kind of perfect surface finish for seals and stuff to work because you need oil inside to lubricate. And I think a cool thing is manufacturing tech often makes old designs relevant again. And with like parallel lever forks like this, I just been calling them double wishbone to not infringe on BMW patents. They sucked previously in like the early 1900s because they were too heavy and the bearings had too much friction. We have ball bearings now, so that solves the friction, and printing composite fork legs solves the unsprung mass problem. So like the entire fork assembly only weighs about like 2 kilos, which is shockingly light for like a motorcycle. So actually the swing arm, if you take a look at it, it's got a whole bunch of like wacky cutouts in the side. And so the problem wasn't making it strong enough, it was making it flexible enough. So when you're riding a sport bike and the bike is leaned on its side like this, your swing arm flex is a large component of your suspension. And if you make it too stiff, you lose a lot of grip. So I spent so many hours in sim trying to figure out how I can make the swing arm flexible enough without it being too weak and breaking. And that was probably the most challenging part. I think as many hours went into the swing arm as like the rest of the bike.
Hi, I'm Tyler Okamoto. I'm a maker, mechanical engineer, and my project is this chicken gimbal. It's a full 4-axis stabilizer for action cameras. So it can stabilize the Z-axis as you're walking. You don't need a ninja walk, and you can get super cinematic shots. So the technology starts with a dynamixel motor. We have an IMU that does the accelerometer, gyroscope, and magnetometer fusion. That goes into commanding the motor to move to counteract the acceleration from the handle. and that's how it's able to stabilize the Z-axis. So right now it's optimized for smaller cameras like the Osmo Pocket 3, GoPros, or your phone, but I'm working on different iterations that it might be able to support heavier payloads like smaller mirrorless cameras or maybe even bigger rigs. But the really big advantage of this is it's super light. So with the camera included, it's only about 1.6 pounds. That's light enough where you can comfortably hold this all day and not get tired.
And that does it for us. Let us know what your favorite project was. Leave us a comment. As always, thanks to DigiKey for making this show possible, and thank you for watching. We'll see you next week.